Evening. Welcome to the Astronomy Association first Friday of the month meeting. We are delighted to have you here. We have people in person in the room. We have people on Zoom, and we also have people on Facebook that are attending tonight. I need to remind people in the room to please not talk at all while we're in the meeting, because Zoom picks up any talking, and we may or may not be, we may be able to understand what you say, but even if we don't, it picks up the rumble in the background. So please be as quiet as you can while you're in the room. We're really glad to have everyone here tonight. We have a wonderful guest speaker tonight. We have Dr. John Barentine, who is a long-term advocate for dark skies. And he is going to share some information with us tonight about dark skies. So we're really pleased to have him. I also want to mention that we have Jim Knoll and Terry Lappin who are helping with technology tonight. And Susan Knoll is going to be operating our camera for us. We ask people who have questions, hold your questions to the end, unless it's something that you felt you couldn't hear the speaker well, or there was something about the screen that you didn't understand. And those are more immediate questions to ask. But if your other questions, we prefer that you hold to the end of the meeting, and we will get everybody's questions, however mode you're attending. We will make sure to address your questions. So if Dr. Barentine is ready now, we will start. We sent out a lot of information about his credentials, so we won't review them here. But we're just really pleased that he's available to spend his time with us tonight and share with us. Thank you.
Thank you. Can everybody hear me? Yeah. All right. Just 2 seconds here. All goes well. You'll see my title slide. Okay, well, thank you, May, for the introduction. I know some of you, many of you I don't, but my name is John Barentine, and I am glad to be back, to be invited to speak on this topic to you again. I was here, I think, January last year, and a surprising amount has happened in this field in even that span of time. So what I'm going to tell you about over the next 45 minutes or so is about something you probably feel like you have a good intuitive sense for. That's light pollution. We're all astronomers. We all talk about this. And a lot of us also think that this problem is hopeless. And we get used to having to drive further and further and further from the city every year to go find really dark skies. But what I'm going to try to convince you of is that things are changing both for good and bad, but that there are solutions to this problem that we know work, and that all we're missing is the will to implement them. And if we do that, we know we can turn the tide. And I'm going to show you some specific examples of that along the way. So this is an outline of what I'm going to talk to you about. First, I'm going to give you an overview of the issue, mostly from a non-astronomy perspective. And the reason for that is, I think we all kind of have an intuitive sense of that as astronomers, what it does to the night sky. But we have learned so much more about this subject as it applies to areas outside of astronomy, which is a good thing in that it is helping us draw more people into this movement to change the direction that things are going. And once I do that, I'm going to take you out to the edge of what we know, show you some very recent results that are both alarming and encouraging at the same time in different proportions. Then I'm going to tell you about the new dark sky Southern Arizona. And if this were 6 months ago, I would have said IDA Southern Arizona. And I will explain why that name has changed. And then I'm going to close with some ideas on how we can save the skies of our region and make sure that to the extent that we still have them, that people who come after us will have access to this resource. So first of all, that overview. And in order to motivate this part, I'm going to have to do a little work in defining some terms. Although I think we all, once again, we have an intuition about what this is. I felt it was important to put a definition up here. And this, to be clear, this is my definition. There is more than one. There is disagreement within the research and the activism communities on exactly what this is. But I'm going to tell you the one that I like is that light pollution is any adverse effect or impact attributable to the use of artificial light at night. And I say that there's more than one definition because some of my colleagues from the life science world might tell you that every bit of artificial light in the nighttime environment is pollution, whether it serves a useful purpose or not. And they would tell you that because all they see is harm that it does to the biological world. The reason that I don't take that view is because I think it might be counterproductive to some of our goals, even though it might be something that you could defend from a scientific perspective. If we want to change the direction that this is going, we need to be very clear about what we mean. And by saying an adverse effect or impact, what I mean by that is there's some harm associated with the use of that light at night. And that implies that there are uses of light that are not harmful, that in fact may be beneficial. And I think we could probably agree largely that there are those uses out there in the world. Humans have had access to artificial light at night on a large scale now for about 140 years since the introduction of electric light in the 1880s, and it has radically transformed our world, right? We're not going back. We're not enemies of progress. We're not here to turn the world's lights off. And with many other kinds of pollution in our environment, we accept or tolerate a certain amount of it because the thing that's doing the polluting is also doing something else for us that's good. So when I talk to people in the policymaking world, they will ask questions like, well, can you tell me how much? What's the threshold? What's the parts per million at which light becomes a problem? And I cannot exactly tell them a number, but I can get into the mindset of them saying, okay, you tell me what's bad and I'll write some kind of law around that. But defining what's bad turns out to be a little more subtle than just saying, here's a threshold, don't exceed it. There's also a need to provide a little bit of a definition for another term that you're going to hear me use repeatedly, which is artificial light at night, that is abbreviated now increasingly, even in the mass media, as ALAN, A-L-A-N. So if you hear me say ALAN, I mean artificial light at night. It is largely what its words imply. It is human-caused light in the nighttime environment. And it can be either indoors or outdoors, as suggested by the pictures here on the right. And for the purposes of this talk, I'm restricting my discussion to the outdoor situation. The indoor ALAN topic is its own separate talk. And it has a lot to do with some of what you might have read about human health impacts, because we get most of our light at night exposure as humans indoors. Not to say that the outdoor light doesn't affect people, because we have some evidence that it does, but mostly I want to restrict this discussion to the outdoor situation. So if I say ALAN, this is what I mean. So here are the few things that I can tell you with absolute certainty. I can tell you, for one, that ALAN is a global phenomenon. Probably you have seen a variation of a picture like this that shows the world at night. There are some NASA products that are literal images they call the black marble, that shows the world as if it were everywhere was night at the same time. And also there's no weather, there are no clouds. And it takes about a year to build up a map like that with satellite images such that you observe every place on the planet at least once when it is night and when there are no clouds overhead. And then they put computers on this to stitch it all together. This particular version that was published a few years ago takes that a step further. Here, the false colors in this image are a representation of what we think the brightness of the night sky at the zenith is in each of those places. So it's made from a source of data that involves the light coming down, going up into space that's detected by the satellite. And they couple that with a model for how that light moves through the atmosphere to predict how bright the night sky is. So as you go from the darkest gray there over the continents, where there's essentially no artificial light in the night sky, on up through the colors, the cool colors, the greens, the yellows, the reds, et cetera, you're getting to increasingly brighter night skies. So besides the fact that there's a lot of it on this map, what does this tell us? Well, for one thing, it goes nearly everywhere that humans go because electricity has become so ubiquitous in our world now. But this is not merely a map of where people live. And I say that because although kind of the usual suspects light up here like North America and Europe, I can assure you there are over 1 billion people who live in sub-Saharan Africa. And it is still much to the consternation of historians, sometimes called the dark continent for some unfortunate reasons. But the reason that Africa doesn't light up as brightly as we do, for example, is that they're not at our level of economic development. And they cannot afford to waste light the way that we do. And in many cases, a lot of those people have no access to electricity. So there's a lot that we can learn by looking at these maps beyond just what is the state of light pollution in the world. And I'm going to show you at a little more granular level in a moment what's going on here exactly. And as I kind of implied a minute ago with the comment about my biologist friends, Alan is biologically active. And what I mean by that is Alan influences the biology of almost every species that we have studied. And we know of at least 160 species of plants and animals, insects, et cetera, that have been studied. And we have reason to believe that essentially all of them react to exposure to artificial light at night. What I'm showing you here in particular is of relevance to humans and by extension to any mammal because the pattern is the same in this case. And what you're seeing are some representations of different kinds of spectral distribution. So you have wavelength running along the lower axis, and you have, just think of this as a relative coordinate on the vertical axis. The first thing to notice is there's a thin white line that's kind of centered on this plot around 550 nanometers. That's the response of the human visual system to fairly bright light. So think about a bright outdoor scene under sunlight. That tells you the relative response of the visual system to light of different colors. Then what I've also shown you here in the dashed line over there towards the left, it peaks around 450. That's the response curve of the human circadian rhythm, which I'm sure you have heard of or you've read about, that all of these activities, these biological activities inside of our bodies are governed in part by this roughly 24-hour cycle that is tied to the rising and setting of the sun, and it recalibrates every day in principle with our exposure to sunlight. And if you look at the chemical pathway that is involved in that calibration, the sensitivity there peaks there in the blue with that dash curve. And then the heavy solid white line there is the spectrum of a white LED, which by an unfortunate coincidence over there in the blue peaks almost precisely where the sensitivity curve for the circadian rhythm is. So we are putting a signal into our biological system when it does not expect it to be there, and when 4.5 billion years of evolution is telling us to be asleep at night. And we are sending a signal to the circadian system that it is daytime. And that has profound consequences, not only for us, but a lot of other species. And it's not even just mammals, it's lots of animals. Plants have circadian rhythms, plants have melatonin, all this. So this is a much bigger issue than just whether we're able to sleep at night, and it goes to our well-being as humans. And then, you know, I probably don't have to convince this crowd that you're seeing the world changing pretty quickly. If you don't think that climate change is real, I don't know where you've been for the past 6 weeks or so. To the extent that the world is still producing about 80% of its electricity through burning fossil fuels, that aspect of climate change is far from over. We've not been able to renewable energy source our way out of this so far. And to the extent that all of that artificial light at night represents waste, and I'll give you a more concrete demonstration of that in a moment, this is carbon going into the atmosphere. And that is even under the assumption that that lighting is becoming increasingly energy efficient. And one of the fun little facts I'll give you in a minute is about how the so-called green revolution of LED is a revolution that wasn't, as it turns out. So now I'm going to take you to the sort of the edges of what we know. What have we learned most recently that is applicable here and is kind of directing us towards a clearer recognition of the problem and also how we're going to solve it? Well, and I'm excited to report this part. Light pollution is having a moment, y'all. In pop culture terms, there's more out there about this subject now than there's ever been. And certainly in the 10 years or so that I've been in this field, there's more recognition of this issue than there ever was before. These are just a few of the publications that have been out in the last several months, in addition to many radio and television and internet spots and interviews and things like that. So there's a gradually rising awareness of the issue. The one in particular that I want to point out that I'm very proud of is in mid-June, over here on the left, we were on the cover of the journal Science for the first time. And there are half a dozen or so really nice review papers in that article that tell you everything you want to know about the subject, what we know about it. I'm the co-author of one of those papers, so I'm really proud that it's got done. That is one of the world's foremost premier scientific journals and is widely read around the world. So to have the recognition that this subject is coming into its own by putting it on the cover, I think was a real watershed moment for us. There's a lot of science to digest here, of course, and a lot of it is quite technical, and in many cases is not very accessible to the public, but there's really important information in there. So we partnered with what is now called DarkSky International, formerly IDA, to publish what we call Artificial Light at Night, State of the Science. We did this for the first time last year. We've updated it this year, and we're going to try to make this an annual event because things are changing that fast. The idea behind the report was we looked at literally what are now thousands of citations from the scholarly literature that are in an online searchable database that some of us kind of curate together, and distilled this down into about 7 or 8 pages under 7 broad subject headings. And we've written it in accessible, non-technical language. And then for each of these categories, when you dig down into it, it's full of citations. There's a bibliography at the end that has more than 300 references in it. So you can easily put this on the desk of your favorite city councilor or US senator or whoever you happen to know in a high place. And their aides, their staff, are the people that really digest this stuff, can get to the information that they need to make informed decisions about policy matters. And increasingly, that's part of our strategy, is trying to change public policy. There is a shortened URL up there, and if you can't read that or you want to scan that QR code with your phone, and failing that, contact me and I will get you a PDF of this report. So what is all of this telling us? One thing is kind of repeating a little bit what I said earlier about Allen being a global phenomenon. It affects a lot of people in the world. The majority of people in the world live in places that are light polluted, in the sense that there is artificial light at night in their environment or in their night sky. That's 80% of the world population. Of that world population, about a third of people or so live in places, or more than a third of people live in places where the Milky Way is not visible at night. And that is a sort of classical indicator of the darkness of the night sky, is whether you can see the Milky Way. And so for very many people, they don't see that at all anymore. And the statistic here that was most startling to me is the last one. About nearly 90% of people in Europe and over half of the US population lives in places where the sky never becomes astronomically dark. It is as though they live in a perpetual state of twilight. So think about at night, if you're in a naturally dark place, you know, it gets darker, darker, darker after sunset. Eventually it can't get any darker. We're fully in the shadow of the earth at that point. For these people, it's like living in that liminal space between sunset and the end of twilight, when the sky is truly dark. And it just never gets dark where they live. This is incredible. Remember, this has all happened in a little over a century, whereas in an earlier era, almost everybody in the world had access to a dark night sky. It has been transformed that quickly. I said I would give you a little bit more granular look about how this is changing. These are some results that were published a few years ago, a little out of date now, but still quite relevant. This is now down to the level of individual countries, and it's based on satellite measurements that were made in the first half of the last decade. So already, this is somewhat old news, but this is the latest and greatest worldview that we have. And what I'm showing you in these two versions of the world map are two metrics that are associated with that satellite data. One of them is, that's labeled area, is the fraction of the landmass of each country where they can see indications of light on satellite images at night. So think of that as just a percentage of the land area. And then the image on the right that's called radiance, that's the total amount of light that they detect in that country, broken down, of course, by country. And then they do it as a percent change over the course of a 5-year observation period with the same satellite, so that the warmer colors, the reds and the oranges over here, mean a greater positive change, and the cool colors mean a greater negative change. And the first thing that stands out is that it's increasing almost everywhere in the world in both of these quantities. So light is appearing more than it was in the past. And if you add up all that light, it's greater than it was at the beginning of the study period. My guess is that if we were to redo this exact study today, we would find that everything got a little bit redder, given what we know. There are a few cases you see where there are some countries that are in shades of sort of blue-gray. Again, this is telling us more about who we are as humans than anything else. A lot of those countries are places where either their level of economic development slipped during the study period, or they were affected by war. And in particular, you can see countries like Syria and Yemen, which suffered from terrible civil wars during that time, and the lights literally went out. If we redid this today, I guarantee you one country in the blue would be Ukraine. If we then break it down by about how much did things change in each of these countries, this is one of the images that went with the press release when they issued that paper, and they kind of bin countries according to the amount by which things changed during that time. You'll notice that many countries in the world fall into what they called a rapid increase. So these were 10 to 50% above the mean for the world. And there were a few that were extraordinary, higher than that. And there were a handful that decreased a much lower percentage at the end of the study period than before, but in many cases, we know why that is. So the takeaway here is that in most places in the world, things were rising. There's an important piece of information I did not tell you about the satellite. All of these numbers are underestimates. And that's because when the satellite was launched in about 2010, the LED revolution had not started yet, not in earnest anyways. And the instrument that they're using to make the measurements of the world at night was not built for that purpose. So it does not detect any light below 500 nanometers in the spectrum. So remember back to the LED spectrum with the huge spike in the blue, satellite doesn't see that at all. That means that some of the changes where there was a decrease are probably more attributable to the fact that the spectrum of the light shifted out of the range of colors that the satellite can sense. Believe me, we are lobbying now to try to get funding to send up a satellite with a proper set of cameras on it that can detect all of that light. And we do get a little of other information from sources like images that are made by astronauts aboard the International Space Station, who, if you look at their images, you can see that the color of the world at night continues to change. So all of these numbers that I'm showing you, these are underestimates, and we don't necessarily know by how much if we don't know how much of a country's lighting stock has already been converted over to LED. So that there's a shortcoming of the satellite, that is, we don't see a lot of the light. One way that we do see all the light is by looking up instead of down at night from overhead. And this is some research that was published just in the last, let's see, what is this, August? So this was in January, so a little over 6 months ago. This is the result of 10 years of observations from a program you might have heard of called Globe at Night, which is run out of Noir Lab right across the street. And what they do is they solicit citizen scientists to make estimates of the brightness of the night sky by counting stars in certain constellations during certain times of the year. And from that, they infer what is the faintest star that a person can see. There's a pretty good relationship between that faintest star that a person sees and how bright the night sky is. As the sky gets brighter, the number of stars that you see goes down. The ones that are left are progressively themselves brighter because they have to stand out against that background more. And so the bottom line in this plot in particular, where they're comparing that unaided eye visual magnitude against a reference sky brightness from, they picked a year, it was 2014, that was their reference. It's showing that, remember, we're getting brighter as we're going down in the vertical sense because the magnitude scale is conveniently backwards. So those lines in both 2011 and 2021 are all trending progressively towards those brighter values, and the slopes are a bit different. And what they were able to infer from this is that as a global average, if you look over all the countries in the world from which they got observations in globe at night, that on average, a person's night sky increases right now at a rate of about 10% per year. And another way of thinking about that is that if a child is born today, by the time they reach the age of 18, the number of stars visible in their night sky has been cut in half, in much, much less than a human lifetime. And again, we only have data on a country level. We just don't have the resolution of the satellite to be able to tell us a whole lot below that. It's also an increasingly difficult computational problem. So we think that if you could drill down increasingly to the level of cities, you would see probably bigger increases than this. And the other thing that I don't think have really appreciated until recently is, even though we have really great lighting technology, and if it were used right, it would solve all the world's problems. At least we could deal with light pollution. If you think about a typical outdoor space at night, and I encourage you to do this when you walk outside after we're done and it's getting dark and the lights are coming on, is ask yourself, if I'm seeing a scene that's illuminated by lighting at night, how many of those photons of light are useful in the sense that they make it into my eyeball? Because if the point of outdoor lighting is to help us see to get around in the world at night, then it needs to illuminate the scene in front of us, and that light has to make it to our eyes to give us information about our world and avoiding obstacles and not tripping over things, right? So my colleague Salvador Vera, who's a researcher in Spain, published this paper earlier this year, where he did some interesting calculations, and his result is so mind-blowing. He's this really very low-key guy. He does not stand out in a crowd, but then he drops bombs like this one. Less than 1 photon out of more than 22 million reflected ones is useful for vision in a perfect lighting installation. So what he means by that is, if you account for all the efficiency losses from different parts of the lighting technology, and you just ask for how many photons leave a light source, how many of them reflect off of the scene and enter a person's eye, it's 1 in 22 million is Salva's number. That is so far less than 1% that it's laughable to describe outdoor lighting as efficient in any way at all. Can it be better? Yes. Salva has some ideas about how we could calculate perhaps an ideal case where not 100% because of the way light tends to scatter in the real world, but could we make that, not 7 orders of magnitude? Probably. And we could do that with better lighting design. And I keep coming back to LED like it's the worst thing that ever happened. And I guarantee you that it's not, but it's inevitable to conclude that at some level LED lighting is making the situation worse. It doesn't have to. I don't think that LED is the enemy. It's not evil. There are a lot of people out there who want to get rid of it completely for a variety of reasons. But we end up with pictures like this because we're simply not mindful about the way it's being used. If it's properly implemented, LED is almost miraculous. It has qualities that we've never had before in artificial lighting. And in particular, we can direct that light to exactly where we want it to go. If you ever happen to be down in that neighborhood, Sahuarita High School has one of the best sports lighting installations in the country. Go see one of their games. They have a lighting system that brings light to the edge of the grass and it stops. And you can get out there, whoever has control of the system, with their smartphone and dial in all of the characteristics of it. Absolutely amazing. But that's because the lighting design was very conscientious and it was with products that were made to do that. So again, we're not hurting for a solution here. We know what works. How do we get more people to adopt the solution? That's the challenge that's in front of us. And I said earlier that I was going to tell you about how LED was the green revolution that wasn't. Some of that same satellite data that we used earlier to make those maps and show you all that detail. One of the things that we learned from that by looking at things on a per country basis for 5 years, looking at the change in the lighting during that time, was it allowed us to compare the change of gross domestic product or GDP in those same countries. That's a broad measure of economic output. And if you plot the changes in the lighting against the changes in GDP, it's an almost perfect one-to-one correspondence. So as countries gradually got richer, they got brighter. And that was true essentially everywhere in the world that they weren't having a civil war. So from that, the authors of this study concluded that this hypothesis that there would be big reductions in light pollution were certainly wrong. And also, it's probably the case that there have been no great reductions in either electricity consumption or in carbon emission due to LED lighting. And the reason is this picture on the left, which is classic economics 101, where in most cultures, if the price of something goes down, we tend to consume more of it and not less. So gasoline is expensive right now. If gas drops by 50 cents, are you going to drive less? Probably not. You know, if it really went down by that much, it's a great time to get in the car and go on vacation. So that's a thing that the economists call elastic demand. And we have evidence now that there's an elastic demand for light. And as light has become cheap, we've just put more of it out there in the world. We didn't have to end this way. We didn't have to find ourselves in this situation. And again, if we did lighting design differently, we could really attack that problem very quickly. There's still a lot that we do not know. This is just a sampling of the questions that are really open right now. We may have some data here and there that kind of give us an indication of where things are going. But these and many more questions are left unanswered at this point. And part of what we put in the State of the Science report at the end of it is a longer list of these questions by category. And these are the things that researchers are working on right now to try to understand better. So I don't want to be all doom and gloom. I do want to leave you convinced that we can solve this problem. And, you know, even on the local level, we can do things that are really meaningful and have a proven track record of improving things once we make the decision to bring about the change. So first, I'm going to talk to you about what we're doing with what was formerly IDA and is now just simply DarkSky. This is something that's been in the works there for about 18 months or so. They decided that there's a lot of legacy associated with the old name, but it's not very snappy. It's not a short thing that comes to mind immediately. So they dropped the international, they dropped the association, and they kept the DarkSky. And technically the home office is DarkSky International. That's the umbrella, but the focus is gradually shifting down to these local chapters or sections that are in many US states now and in a number of countries overseas. So the international part is sort of implied. And they even kept some of the branding with the new logo to suggest a continuity of these ideas. So if I say DarkSky or you see it written without a space between those words, I'm referring to the organization. And we are in the process of rebooting this chapter. Things kind of went dormant during the pandemic. You may have heard of the pandemic. It may have affected your life. For some of the folks that were in the Southern Arizona chapter of IDA, it affected them very seriously. And on the other side of it, they decided that they weren't really in a condition to keep going with this. And about that time, we were contacted by a couple of college students, one of whom is standing there in the center. This is a sort of an initial meeting we held in May to try to figure out what could we do. You know, is it worth trying to start this anew, to create a new chapter? And it was really spearheaded by that fellow in the center. His name is Zane Landers. And the reason why he's holding his phone up for our little group picture is because the other student, whose name is Duncan Yuen, they're both students here at U of A, was on Zoom from his internship in Colorado or in Chicago for the summer. So he was able to meet with us remotely. And we charted a new path. And since then, we've held a couple of events. We had an open house in June. I was shocked. We had 40 people show up on a Wednesday night in June that wanted to come talk about dark skies from the Southern Arizona area. And we got together a core group of people that want to be a little bit more involved. We have a board now. We've elected officers. We have new bylaws, and we're starting to do some strategic planning for the first time ever in this chapter's history, which, again, credit to people who preceded us. And they did a tremendous amount of work in education and public outreach. They were at a lot of events. But like a lot of the other chapters of the organization, it was always pretty reactive in terms of what they were sort of trying to do out there in the world besides the education. If something came up, they might try to put some people on it. But I think one thing that held them back was that they never had any particular goals that they were going after. So we're right in the middle of this right now. We're coming up with a new strategy that will lead to a set of goals that will eventually lead to a set of tasks. And if we need resources, we'll go out there and find them. And to start us off, we held a discussion last month where we took the sort of whole universe of ideas of what we could do and then realized, oh, wait, we're a small group of people. We probably better narrow this down to things that are increasingly achievable. And we came up with these 4 areas that we want to concentrate in over the next few years in Southern Arizona, starting with public policy. I think I probably left out the slide that I wanted to show you. We're in the midst of doing an analysis of all the lighting ordinances across Southern Arizona in the counties and the municipalities to figure out how long ago were they revised and what sort of things do they have in them. And if they're not good, we want to put more things into them. We want to get support in the communities for making the changes because we know with evidence that lighting ordinances are effective. And I would point no further than here to Tucson, which, yes, there's a lot of light here, but also for an American metro area with a population of over 1 million. I can stand outside in my backyard on the eastern edge of the city and I can see the Milky Way, no problem. Try doing that anywhere else. That's a testament to the lighting ordinance that we have shared in City of Tucson with Pima County since 1972. It was the first in the world of a comprehensive nature. So we definitely want to further that. We want to do measurement and monitoring of the brightness of the night sky. If you want to go talk to people about the degradation of a resource, you better be prepared to show them some numbers. We know of a few monitors now. We want to put a lot more out of them out there. We want to support the International Dark Sky Places program, which is the organization's flagship conservation program. We have a few of these designated places in our region now. We'd like there to be a lot more of them. And one thing that we can do is provide expertise. We can provide volunteer hours. We can help them get through this process, which as somebody who formerly ran that program, I can tell you it is not easy to get through it. And then lastly, we want to continue the legacy of the version of the chapter that preceded us and get more involved in education and outreach, especially in schools. It's a little cliche to say that children are our future, but they really are. And believe me, kids get it. You've all done star parties. You start talking to them about almost any subject. Kids get it. They get light pollution. They understand what we're talking about. Okay, so to illustrate these, to give you a sense of geographically where things are, I'm going to tell you a story and a handful of maps here. And they're going to be variations on this theme. So this is my sort of overview of Southern Arizona in terms of light pollution. And it starts with, there's a satellite image in the background. That's just a Google Earth background. And then over that, I've laid white lines that are the county boundaries, just to give you a sense of where those are. And then over that, I've laid a series of false colors that are kind of like that map of the world that I showed you earlier. As those colors get warmer, it means that the sky is brighter at the zenith than it would be in an area where you can see through that layer into the background. And then to show you the extent of how far that light is escaping from our cities, this sort of like rough, grayish, patchy looking stuff that's over the cities, that's a set of grayscale data that's the actual satellite images. This is a composite for the year 2022. So it's the most recent data we have available. And what I'm showing in that, where those contour edges are, that's the last sensitivity contour of that instrument. So below that, it calls it 0 in the sense that it's seeing 0 light coming up. So that kind of defines the edge of the built environment more or less, but you see that the colors extend very far out from those edges. So Where is light coming from the cities? How far is it going? I've kind of compressed all of that into this image. So I'm going to put some symbols over this to tell you a few things. This is where my slide was supposed to go for the ordinances, and I'm sorry that it is not ready. I will show you that next time I come back. Here I've put some symbols that are meant to indicate our international dark sky places, which are in the blue, the little blue dots: Tumacacori National Historical Park, Karcher Cavern State Park, Oracle State Park, Chiricahua National Monument. These are the places that have already come through the designation program successfully. There are others in the works. Town of Oracle is interested. Town of Tubac is interested. A couple of the other state parks potentially. And I've also put in the little black markers where our observatories are, because that's an important part of the economy of Southern Arizona. U of A released a study earlier this year suggesting that space science and astronomy and planetary science at U of A alone generate roughly $500 million of economic activity a year, which by coincidence is about how much you can expect to receive as a Super Bowl host city. So here we are, just quietly generating as much economic activity as the Super Bowl every year in just Southern Arizona. And I would suggest that maybe that's worth fighting for, because it is a part of our economy. So we want to protect the observatories as well. We're looking at a lot of spots around here where there's potential for future international dark sky places. I kind of like the Kofa National Wildlife Refuge. It's up in the border between La Paz and Yuma counties. It's technically in our territory. It's pretty dark up there. The whole area down here around the border south and west of Tucson is part of something called the Sierra Pinacate UNESCO Biosphere Reserve. It's cross-border. It involves the Tohono Nation. And we think that would be a fantastic place for an international dark sky sanctuary. Gonna have to do something about Lukeville and Sonoyta, one thing at a time. And then over in the White Mountains, part of over there in eastern Arizona, and even a sort of a greater designation for the Chiricahua area is something that I think we could do long term. And then I mentioned that we wanted to put some more monitors out there and start getting more sky brightness data. The purple symbols here are where we know there are monitors right now. I think there are even more of them that we don't know about. And the red symbols are where we want to put them. And we're developing a funding proposal right now to go out and get the money to do precisely that. Make all the data publicly available, have some kind of nice web interface where you can go and snoop and see, you know, how bright is the night sky out in Ajo on a given night. Over time, we'll build up a very important time series of data that will help us see how things are changing. So that if I need to go get a meeting with one of the governor's staff and say, look, we have a problem, here's the data. Let me show you how things are changing in Southern Arizona. And need I remind you that that's $500 million a year on the line. So lastly, in just the last couple of minutes here, what I want to do is tell you about how I think the broader, longer term approach will go so that we can make ourselves a model for the rest of the world to follow. And the first part of that is what I call building on local success. If you've been around in Tucson for a while, you remember a few years ago, we got brand shiny new LED streetlights. And on the surface, when I was sort of trash talking LED a little while ago, you would think I would say that was a terrible thing. I would say that our conversion to LED was exemplary. And we know that because we measured it. We measured the brightness of the night sky before and through the transition to LED lighting. And because of very careful attention to the lighting design, active controlling of the light during the overnight hours, and a serious reduction in the light emission output of the lighting, we were able to see the decrease from space, even accounting for the satellite being blind to some of that blue light. And we also saw the sky get darker, especially at intermediate and long distances from Tucson. We saw measurable decreases of up to 20% at places like Kip Peak, if you can believe that. And the signal lines up exactly in time with when this was happening in Tucson. We can do it right. Other cities in our region have not gone through the transition yet. We want to encourage them to do things like this. So let's build on our successes. How can we do this? We want to pilot something that nobody in the world has ever done before. And that is, we want to come up with some kind of resource management district for darkness. And we want to model that on our water conservation districts right here in Arizona. We all know that without water, we are in a tough spot. out here in the West. And sustaining a population like this in a desert is a big challenge. So many years ago, the jurisdictions of Arizona made maps like this on the left that show the drainages of all of the major waterways in our state. And then they mapped them onto different associations of governments, counties, municipalities, et cetera, and came up with these water conservation districts. And that's how we are managing our water in a time of both growing population and a drought unlike any that has been seen in Arizona for 1,200 years. We're doing okay, all things considered, because we're very conscious about water flowing in and water flowing out. Could we do something like this for light? Some of us think we could. I say light conservation districts, really it's darkness conservation, but the resource that's being managed here is light. So I've taken that false color map of the brightness of the night sky and I've laid it over a map of some of the associations of governments across Southern Arizona. And we could start by kind of chunking this up and talking to those governments and seeing who we can get on board. We think Tucson is a great place to pilot this. And the idea is over time, if you want to build a new development over here that's going to bring a lot of light, you have to take it away from somewhere else. But you allow for the growth. You assume that we consume light at a certain rate, sort of per capita. You let that growth happen. But if you have a lot of light here, you have to take it away from somewhere else. If we could convince enough governments to do that, we could finally deliberately control the rate at which things were changing, something that no one has been able to do before. So this is our longer term little pet project. And then last, I'm going to leave you with these two things. And I mentioned lighting ordinances previously. Even though they are effective, they work. We know that. We always have to deal with the fact that our population is in flux. There's always this development pressure. Holding the line is tough, but we can do that if we build and maintain support for good outdoor lighting policies. So that's one thing. And then the other thing that sometimes people look at me and they say, John, okay, fine. I'm not political. I don't want to get into politics. Everything is political in our country and really in the world. And people that are willing to play that game are the ones who are going to win. So when I say we need to cultivate values voters, I don't mean partisan politics because I do not believe that this is a partisan issue. Rather, what I mean is we need to tell people the value of this resource, bring them to the point that they really believe that's true, and let it inform their decisions when they vote. And that can be for whichever party they prefer, because it is an issue that crosses partisan lines. If we ingrain this sense of darkness and the preservation of night skies as a value among people, much the same way that the environmental movement has been pursuing the same strategy now for a long time, will bring up a generation of people who value it enough that when they go to make these decisions, it factors into that. It may not be the overriding thing, but at least it factors into it. And if we can do that, I think our future is in good shape. So I'm going to leave you with this last thought here and with a picture of Kitt Peak to go along with it. And if you've been out there, can't go out there right now, but if you've been out there in recent years, you'll know that that image is taken looking north. That glow, that's not Tucson. That's Phoenix. Tucson's over here, right? The future of images like this and other places that we know and love across Southern Arizona, that future depends on the choices that we make today. It's like with a lot of other things that we're confronted with choices. I think there is cause for alarm, but there's also cause for hope. Again, we know what the solutions are. We know that they work. We just have to build the coalitions of people who will support actually implementing them. And if we do that, I think our future is indeed bright for the right reasons. So with that, I thank you for your attention and happy to take your questions.
Okay, do we want to start with Zoom questions or in the room questions? In the room, okay.
Thank you. I've asked this question several times at different organization meetings, including the open house. And I don't mean to go all doom and gloom. In fact, I was giving the Tom Wright Howard presentation to the Adirondack Astronomy Retreat. And I noticed in his notes referring to a guy who was asking this question, I realized he was talking about me. So I got to ask it anyway, just to see if you can give insight. I'm not looking for an answer.
Sure.
But we talk about being positive and optimistic. And I'm here in Tucson. I'm here at the University of Arizona, one of the top astronomy programs in the world. By the way, I asked this question of the Dean of Science a month ago and pinned her down. We build mirrors under the football stadium. I live on the northeast side of town. Yes, I can see the Milky Way to the east, but I live on a little bit of a hill and I look to the southwest, and guess what dominates the horizon there? Our football stadium and a couple other stadiums. At 2 a.m, they're supposed to turn it all off. And if Sahuarita High School can do it right, why isn't the top astronomy program or one of the top astronomy programs in the world able to do this?
I would encourage everyone in this room to call President Robbins' office and ask that very question, because he doesn't have a good answer for it other than money. Money. It's in my opinion, it's shameful. I got my undergraduate degree at this institution. I'm a very proud Wildcat. A million years ago, I was a student in this room, and it is very disappointing that this institution is not a leader in this community in that regard. And if nothing else, name and shame, because this institution can and should do better, and there's no excuse for it. That's my answer. Mm-hmm.
And I'd really like to second that, from being a long-term employee and person associated with the U of A. Community response can make a real difference, and particularly sometimes when it's going directly to the president's office. If it goes other places in the university, it doesn't get to the president. That communication is not going to go upward if you send it. So you want to talk to people like the head of the astronomy department or the head of science or President Robbins. You've got to get your communications to those kinds of people. And if you get enough coming in, I really do think it could make a difference.
They need to hear from students. They need to hear from alumni in particular. Believe me, you get the alumni behind something and things will turn on a metaphorical dime.
Absolutely, because alumni are donors. So anybody that gets associated with being a donor to the university, can really impact on this. So if you know donors to the university, and people who send money like to the U of A Foundation or something like that, then great. Start, getting those people to communicate.
I don't even get the money argument, because you just said how much money astronomy brings into Southern Arizona, and football brings a lot of money in too. It seems that this should be affordable. In fact, it might be a great investment. But anyway, I know I'm preaching to the choir. Thank you.
Okay, hands. Let me see. I'm looking on way up.
Bear
We've
down.
got one right here.
By the way.
I know back, I'll get
Okay, I just have a further question for, is that David?
Yes, that's David Ross.
Rossiter? Oh, hi. Hey, were you saying that that they leave the lights on all night? The floodlights at the football stadium here? And you can see them and you're out. She,
Yep.
Can David's answering the microphone. Got that, David?
Thanks for the question. Yes, I'm 15 miles away, and I've got light trespass from the football stadiums at the university through my front windows. Yes.
Thank you. Good question.
inexcusable.
So that's part of what you say in your letters is inexcusable.
You said the measurement was important to have numbers to go lobby. Have any idea what the cost would be to what he's talking about?
Oh, that's a really good question. One thing that I can tell you is that The kind of equipment that you can see if you go down to Sorita is more expensive. I will admit that, because right now the market for it is small. Over time, as that market grows, that cost will come down. By and large, it's a little bit different with sports lighting, but by and large, there is no cost penalty to putting in good lighting. It used to be that if you wanted to get the warmer color temperatures and the proper shielding and all of that, that those were options, but it's become so mainstream now that it doesn't cost any more to do this right. So there would be a material cost to the university if it decided to do that. It's hard to say exactly what, but I'm pretty safe in saying that it's less than what the athletic program generates in a year, let's say.
Okay, other questions, other hands in the audience?
How could modern astro imaging cameras be used to monitor light pollution?
That's a great question. I think any image that you take, you are getting light pollution information in it because you are imaging the sky, right? No matter how deep you go in an exposure in essentially any part of the sky, you get enough of the sky where there really isn't something. There's not a detectable object. It's hiding there in all your images. The challenge is in extracting that information and then what you do with it once you have it. But the short non-technical answer is that all of that imaging has that information already encoded into it. Even your old stuff, if it's got dates on it, we could go back and pull historical information out of it. So yes, and something, a longer term idea that I have for some of the other organizations I work with, like the American Astronomical Society, is bridging the professional and amateur worlds and finding ways that amateurs can contribute their images. And then we could put some software in an automated way on it to just go and extract that information. And it would be all, you know, if you have headers in your images, it's got information on where you were located, et cetera. And we could feed this, give it to, let an AI run with it and let it come back and tell us what the answer is. So yes, it's there and it's valuable.
Okay, any other questions in the room?
Go ahead and get some from Zoom. I'll just use this microphone, May.
Okay.
Before I get to the Zoom ones, I have one comment and a question for you, John.
Okay.
One comment would be, I noticed you had a monitoring station at the Chiricahua National Monument. Our Chiricahua Astronomy Complex is not too far from there, so we would love to be able to put another monitoring station there down the road. So let's kind of keep that in mind.
Mm-hmm.
And along that same line, is there an avenue for places like our astronomy complex to get dark sky certified in a category?
So there's two things there. One of them is about the monitors. Yes, we would absolutely be interested. If anybody wanted to, we've had some inquiries about this. People say, well, what if I just want to put up one of these at my house? You can get a good scientific quality monitoring system for roughly $500. It's really not an expensive piece of equipment. And so that's why we're going after fairly what amount to low dollar funding asks. We can do all of those monitors that I put up there we ballparked it at about $17,000, including building the back end and all of that to receive the data. So that's certainly an option. For sites to get certified, it depends on a few things. Sky quality is part of that for certain of the categories in the program, but not all of them. That's one of the bedrock things. The other thing that sometimes is difficult for privately owned properties is that you have to provide public access as a condition to receiving the designation on some kind of a meaningful basis. That doesn't mean 24/7, 365 by any means, as long as the public has an opportunity with reasonable frequency to access the location at night.
So like when we're doing our Evening Under the Skies, when we open the site a couple times a year and we do other kinds of events there, that might get us in
that
there.
might get you there. Yes, you'd have to talk to Amber at DarkSky and she'll tell you.
Okay, let's see, there's a couple of on Zoom. Peter asks, IDA headquarters was in Tucson, correct? Will DarkSky continue to have its main headquarters in Tucson?
Yes, Peter, the short answer to that question is that DarkSky is not going anywhere. This has been the home of the organization for 35 years. And for all I know, it will continue to be. That's the intent.
Okay. Alan asks, why can't we go to Kit Peak today? I don't, there's probably, I don't know if you know the answer to that. I think part of it is because they're still working on the road going up there.
Yes.
And they haven't finished the guardrails and the safety equipment, but I'll let you cover any more. If you
That's
got-
correct. Because of the damage that was done during the fire last year, the mountain is still closed to the public. And that's because it did take out a lot of guardrails that they're having to put back. Don't quote me on this, but rumor has it that Kid Peak will reopen in about November. They're making good progress.
Excellent. Richard asks, and you already alluded to this, how expensive is light monitoring equipment? You already kind of covered that.
Mhm.
Let's see, we have a question. Does the bright white roof coating used in Arizona also reflect and compound night glow and light pollution?
Oh, I'm glad somebody asked about that. So I grew up in Phoenix. And last time I was up there, I was in a part of town where they're experimenting with putting a reflective coating on the streets. I'm like, I get why they're doing this, right? They're trying to reduce the impact of the urban heat island. But then I thought, okay, there are street lights along the street because Phoenix puts at least one street light on every residential neighborhood street, in addition to all of the thoroughfare streets and all that. So now you have this surface that's much lighter in color than even worn asphalt. And worn asphalt is surprisingly reflective, right? So then it becomes kind of like in places in the world where it snows in the winter. I could show you, happy to share it with anybody. There's a site you can go to where all that satellite data that I referred to are available in time series form. So you go into the map, you draw a boundary around an area, and it comes up with this beautiful plot that shows you how much light came from that place every month going back to 2012. So I start drawing circles around places like Chicago and Salt Lake City and New York and places like that. And curiously, every year in December and January, bloop, bloop. It's because snow on the ground is amplifying the light that's being sent down towards the streets. So my intuition is the roof coatings would do the same thing, but by and large, they're above the level of the lighting. I think most roofs are dark, maybe with the exception of some of the like commercial warehouses and those sorts of buildings. But my guess is that the roof coatings in residential areas probably aren't contributing very much, to be honest.
Right. And last question on here. Are you going to work on really bad lights in Tucson like those at the TEP power station? That was from Tim. That was from Tim Hunter.
Oh, that's another one of those. In my mind, I have a hit list, that I want to go and take these down one at a time. It's a combination of things, but yes, we're always fighting the awareness battle, right? And we will continue to do that because we have generations of people coming in behind us, and we have new people moving into the area that are not from here. And they don't, even though the concept of dark skies is probably socialized better in this part of the country than maybe anywhere in the world, people come in from, hi to my friends in California, but they come in from places like California and they bring a completely different mentality. They're not coming from a culture that values this so much. And so we have to go through the education process every time. So some of the bad lighting that you see, I think, is not people doing anything nefarious. They simply don't know what the law requires of them. But also, I think we need to lean more on the city and county to do more enforcement work. There is a mechanism for reporting lighting code violations. The city is not exactly quick to deal with them. If you're persistent, it will. And at the end of the day, that's going to mean more resources that the city needs and county need to pursue that. So yeah, in short, that's one of those places. The power stations were a little bit at a disadvantage because some of that lighting is required by federal law, is it's a workplace safety issue. So we may not necessarily, it's the same thing with the airport, but if you've been here long enough, you remember how terrible the lighting was in the parking lot at the airport. Now it's beautiful. And that same mapping site where I said you can go get the little time series, all the measurements, you can see exactly when they updated the lighting at the airport because suddenly the airport got a lot darker. It really works.
And one final question, does the Planetary Society, actually, there's two more. What is status of electronic billboards in Tucson and surrounding area?
The electronic billboards are an issue that keeps coming back. They are permitted in city limits with some pretty severe restrictions. That's true of some of the neighboring municipalities like Sahuarita. If you get outside of the cities, it now becomes a state issue. We fought a battle, a pitched battle against the outdoor advertising industry in the state in about the year 2010 that resulted in what is the current state law that permits billboards along certain highway corridors like the interstate highways with, again, pretty significant restrictions. So you see them on the freeways up in Phoenix because they're allowed there. They're not allowed here because the law carved out these exception zones around the observatories, which is why they are not on I-10. But if you go up to Phoenix at night and you're driving through town, those lights are off at 11 o'clock. They're off. That was part of the deal. It seems like about every second or third year, the advertisers come back and they want to weaken the state law. And every time we go to bat and we have to remind the legislature and the governor how important this is. And we've been able to stave off sort of the worst of it. But the trend in outdoor advertising is more towards these signs, right? You can pack more advertising onto a sign that you can dynamically change like that. So there's this uncomfortable kind of an equilibrium that we're in right now. They keep wanting more, we keep pushing back on it. Again, there's a happy medium in here. DarkSky has a set of guidelines for operating those kinds of signs that can be translated into policy language that they have been promoting jointly with the Illuminating Engineering Society. So the real experts in lighting have gotten behind this. And I think the bottom line is we just have to stay on this issue. And if we keep coming back and telling them how important it is, you know, dark skies has this value to our economy, et cetera. Hopefully we can keep it at bay.
And we seem to be seeing a proliferation of LED signs on businesses and schools as well.
do,
And that's a
you
whole
do.
nother, I don't know if that must not fall underneath the same regulation.
No, it does. And it's regulated by the Tucson Pima County Outdoor Lighting Code. That's again, a combination of a lack of awareness on the part of the people that operate the signs, but also they get permits for signs under the impression that they're going to operate them at a certain level. And then they get a tech who comes out and messes with the electronics and suddenly it's twice as bright as it was before. And there's not a good enforcement mechanism right now.
All right. And one more question on from Susan on Zoom. Does the Planetary Society help with this issue? So I was talking about the electronic billboards. I see it on Facebook with the cast from many seasons of Star Trek.
That's an interesting question, Susan. I don't know that we've ever heard from the Planetary Society in particular, but in a way, what we're interested in overlaps with their interests, even though they're kind of more focused a bit outward. I've said for a long time, we need a good celebrity spokesperson, right? We need a celebrity with really good star power to take up this issue and talk about it when they do media interviews and that sort of thing. Since Bill Nye from time to time endorses the Planetary Society, and I think he was on their board at one point, he did a little blurb for us a few years ago talking about light pollution. So somebody like that or Neil Tyson or whoever would be really great if they, you know, if you're listening, Neil, call me.
All right. And lots of accolades about the talk. Everybody loved it.
Well, thank you again for having me. I really appreciate it.
So anything on Facebook? On Facebook. Okay. Anything else in the room?
Thank you so much, John. We really enjoyed that. And we hope that we can keep up with what's happening in the light pollution efforts. And so, you know, if we could have a nice interface with TAAA on some kind of regular basis, I think that would be wonderful. And we can keep up with this and we can also, you know, work together to advocate because when TAAA becomes aware of these issues, like something with the lighting code, we normally participate and try to help. And so, but, we can miss what's happening. And so if we can work on, communicating about those things a lot, then, perhaps we can get more TAAA activity and support.
We'd like that as well. So please do. Feel free to contact me or the chapter.
Right.
Okay.
Right.
Thank you.
Okay. But is the chapter now having open meetings like at a certain time every month or something? Or
We're
are they
not there.
doing those meetings right now?
Right now, we're still kind of getting our structure together, but our intent is probably by this fall, we'll set a regular meeting schedule. And we intend to meet at the headquarters office, which is over at about Broadway and Rosemont area. So it's kind of central.
Well, if once you start that, if you could let us know, we have a spot in our newsletter where we can stick that in.
I commit to doing that. So
Okay.
yes, thank you.
Right, sure. Thank you very much. Okay, so we really appreciate your coming, and we do hope to have you back on a regular basis. Now, I don't think that we have other activities tonight. Oh, Eric's here. Yes, Eric. Wonderful. We have Dr. Eric Kurkashka, who is going to give our planet report of the month. Thank you so much, Eric.
Okay. In the evening sky, we have Mercury, which doesn't get visible very often, but now for up to mid-month or so, you can see it pretty low in the west when it's halfway dark, around 8 p.m. or so. And Mercury is not lonely there because Mars is just a few degrees to its upper left. About distance is about 5 degrees or so. And right now, both planets are still reasonably well visible, but then they get closer to the sun, and so later in the month they won't be. So this week it's pretty good. And then the way they are closest together will be around the 13th. That's when the distance will be less than 5 degrees. And the really nice day is the 18th, because the moon will be very close to Mars at that time. Although Mercury will be far enough down, so you probably need binoculars to see Mercury at that time. And so Mercury is right now is faster than Mars, so it's trying to catch up. But then later it will get retrograde, so it will stop, and Mars will get away from it. The planet that's up all night is Saturn, because on the 27th it gets in opposition, so it's up all night. And right now the rings are not as open as they were. The size is 43 times 6 arcseconds, so they are 7 times as long as they are wide. So it's getting narrower, and our next year will be even narrower than that. By now, Jupiter rises before midnight in Aries, and so it will become an evening planet pretty soon. Then Venus was in the evening sky for a long time, but now it's switching to the morning sky next week, actually. And then on the 18th, it will become visible in the morning sky. And it will really quickly become very obvious bright planet in the morning sky, because it rises quickly up. By the end of the month, it will be a nice big crescent, 10% illuminated. So even in binoculars, you can see the crescent, and in telescope, it really will look nice in the morning. The location of Venus, by the end of the month, it's high enough so you can see stars around. And you can notice it's near the head of Hydra, the water snake. And no other planets get to that, because it's not one of the zodiacal constellations. It's far away, but Venus is really far away from the ecliptic right now. And that's where it wanders retrograde for the next few weeks. The planets Uranus and Neptune's up Uranus is 8 degrees of Jupiter, not too far from it. And Neptune is 20 degrees east of Saturn. They rise pretty late, but they'll come in opposition pretty soon too. The unusual event this month is that the moon will be called Antares, which is well visible in the evening sky in the south right now on the 24th. And its occultation is a convenient time from 7:03 till 7:58. So roughly 7 to 8 p.m. The Antares will go behind the moon. And when it enters, it's only a few minutes past sunset. So the sky will be too bright to see Antares naked eye, but if you have binoculars or a telescope, it will look really good. Although, because it's not dark yet, you won't see the dark side of the moon where it will go behind. The moon will be about half moon. And then at 7:50 m, it will come back on the bright side of the moon, but that time it's dark. But it's not as impressive because the moon itself is bright, but the contrast of colors of the lightly yellowish moon with the more reddish Antares will be beautiful too. So it's worth to watch on the 24th from 7 to 8 p.m. And then the Perseid meteor showers, they're always in August. There are already a few Perseids visible, but the maximum is around the night from the 12th to the 13th. And the moon won't be around, so it really will be dark if you get away from the city. They are really fast meteors, 60 kilometers per second. So it gets you from Tucson to Phoenix in 3 seconds. That's good speed. And if you imagine that the meteors that you see, the faintest one may be a millimeter in size, and some of the brighter ones may be 1 centimeter in size. But the separation between those particles is about 100 kilometers. So the distance from Tucson to Phoenix. So those little particles and so far separated. So there's really not very much dust in space, but when it gets into the Earth atmosphere with that speed, we can see it. So hopefully it will be clear because it's not always clear in August, but let's hope for the 12th or 13th or so we can watch some Perseids. Thank you.
Thank you very much, Eric. And Eric puts his monthly planet report on the website. And so anyone who forgets part of the report and you want to look it up, you can check the website. I want to say goodbye and thank you to our Facebook people for joining us tonight. We hope that you'll look at our website at TucsonAstronomy.org. And we have lots of astronomy information there. We have information about the club. We have activities you can do with children. And we hope that you will come back and join us. We're here the first Friday of the month at 6:30 and have a whole variety of different kinds of presentations. So we hope that you will come back again and join us, and thank you for coming tonight. I also, for people who are attending the meeting, I want to thank you for coming tonight. And for our people who are here in person, Sherry has brought some refreshments that will be in the lobby that you can share, and Sherry had to leave early, so Suzanne is setting them up for you, and Doug has brought some drinks, and so we hope that you will go over and have some fun chatting with each other, and we hope that John could join us and chat with us for a while. So unless there's something else that we need to announce, okay, we will close for tonight.